Welcome back to our course on trusses. We will discuss the Wichert truss. A Wichert truss is a truss that has successive supports, three successive supports as shown, A, C, and B. The true problem here is in computing the vertical reactions YA, YC, and YB. We can never achieve one equation which has one unknown, and therefore we will proceed solving several equations in several unknowns. Starting with the easy reaction XB and considering sigma forces in the x direction equals 0, we have a tan horizontal applied force at joint 1 here, which is in equilibrium with XB. This gives that XB equals 10 tons. The vertical dimension here is 6 meters and the truss consists of 6 panels. A2 is one panel, 2-4 is another. Each 6 meters and the total span is 36 meters. To proceed with our calculations, let's note that the support at C here, the support at this square vent or rhombus vent is a clue support for the solution. And we will start with joint C and we will conclude now a relationship between the internal forces in members 4C, C6 and YC. So let's consider the joint method and take joint C. Let's extract it outside here. Let's start deducing a relationship between the two internal forces first, the force in member C4 and the force in member C6. This is done by taking the equilibrium in the x direction. Of course, we will analyze each force into its vertical and horizontal components. And note that all angles here are 45 degrees. Considering sigma forces in the x direction, here we consider the horizontal components, and this concludes that the internal force in member C6 equals the internal force in member C4, and let's have the notation as F for simplicity. Considering the equilibrium in the y direction, here we will relate the force F with the reaction YC. Considering the vertical components here and the YC, we get this equation which gives the force F equals minus YC divided by 2 cosine alpha, where alpha here is the angle 45 degrees. Of course, in this equation, we substituted for the forces C4 and C6 by the force F. We proceed then, and taking sigma moments about A for the Wichert truss, we will get a relation between the two reactions YC and YB. Here we are. Now, since the vertical 8 blue tons is repeated, we will have it as a common factor and we will add all the arms of it to reach A. So we have the first arm of this 8 tons at joint 1 equals 6, the second 12, 18, 24, 30 as shown, and YC has an arm 18, YB has an arm 36. This gives the relationship between YC and YB as shown in this equation. Now we have our equation computed previously, and we have a section We take the right part, extracted outside for computations, and we start our equations. First, we analyze the force in member 601. Here, the inclined member here, 601. And member F, which is member 6C. And we recall, of course, that we have the relationship between the force in the inclined members connected to joint C and the reaction YC. We have this relationship previously detected. And we take sigma moments about joint O1. So the only internal force that appears here is the force F. Okay, force 601 and 501 are cancelled as they both pass through the joint O1. And the only external force unknown is YB. So we have one internal force and one external force unknowns. We have our equation here. 8 tons at joint 5 multiplied by the arm 6 and another 8 at joint 7 multiplied by the arm 12. The 10 tons XB rotating in the same sense about O1 and multiplied by the arm, the vertical arm here until we reach O1 equals 6 meters also, minus YB rotating in an opposite sense around O1, and the arm between B and O1 is the horizontal projection between B and O1 equals 18 meters. The force F is taken as it is in its position without its analysis, and therefore the arm is the perpendicular from O1 to the force F, which is really the distance O1, 6. This is 6 meters divided by cosine 45. This gives another relationship between YB and F. Substituting for F from the above equation here previously computed in terms of YC, we get a relationship between YB and YC. This is the second relationship between YB and YC. Here we are. So we really have two equations in two unknowns YB and YC. The first one over here is computed from moments that were taken about A. The other one here is computed from the section. Please note that this section we analyzed a part that contains only YB, but YC appeared because it was substituted for in terms of F. Solving the two blue equations here in the two unknowns YB and YC, we get that YB equals minus 9.33 tons, which says that we assumed its direction wrongly and it's really heading towards downwards. And here is the value. YC equals 62 tons and is plotted on our diagram here. Taking sigma forces in the y direction equals 0. For the whole truss, we compute that YA equals minus 12.67 tons, heading downwards, and is plotted on our diagram. The 8 multiplied by 5 here is really 8 tons repeated 5 times on the truss here. Now all our reactions are computed, and it is easy now to compute the internal force F for the members C4 or C6 connected to joint C from these equations. For the internal forces, we have one equation and the other equation. Substituting for YC, we get that F equals minus 43.84 4 tons. This F is the force in members 4C and 6C. In our example, it is a compression member. And now we can proceed with any other internal force in any member to be easily computed. So we have F. If we analyze the force in 601, we can easily compute it, and we can easily compute the force in F01, and we can proceed with any other member. We will not go into details of internal forces, as the clue issue of this truss was solved, and any other member will be computed systematically, as has been done in many examples before.